Okay, this is a homework question. So this one, because it's a cube root and not a square root, or if it was a fourth root, you'd have to do the greater than or equal to any even index on the outside. You have to restrict it. But because it's an odd root, you can take an odd root of a positive, a negative, 0, doesn't matter. So that's why it's all real numbers. For number 7, so now I've got a square root in the top and something in the bottom. So the bottom cannot equal 0, which means x cannot equal -5. And the top has to be greater than or equal to 0, so x has to be greater than or equal to -5. So these were the ones that, remember Friday's video that we didn't get to watch in class? These are the ones that are like that, where you've got 2 restrictions. For me, I think sometimes the easiest is to see the visual of it, and so I would map it out on my number line. So if it says x is greater than or equal to -5, that means it's got a bracket, and it would be pointing to the right here, a solid dot pointing to the right. But it can't equal -5, so that changes that bracket to an open dot. So now it's just greater than -5. So it can't include -5 because of the bottom. For number 6, same kind of concept. So this has to be greater than or equal to 0, and this cannot equal 0. So s cannot equal 3, but s can be greater than or equal to 2. If you look at that on your number line, 2 and 3, 3 you can't have, so it skips 3. But it can be greater than or equal to 2. So it's greater than or equal to 2, except where it's 3. If this was an interval notation, it'd be -2 to 3, union 3 to positive infinity. But it's all those numbers except the 3 because it's in the denominator. And the same thing, oh no, this is the reverse. So this one, anything in the numerator is fine. I don't have to worry about that. But the bottom has to be greater than 0. It can no longer equal 0. So x has to be greater than 9. So all real numbers such that x is greater than 9. It can no longer equal 9 because that 9's in the bottom. Or the 9 would make the bottom 0. So 2-3, analyzing graphs of functions. On Thursday, Friday, we talked about domain of functions. We talked about how to find the zeros of the function. We find out all that stuff. Now we're actually going to talk about the graphs of these functions, okay? So the domain and range from a graph, we did domain from an equation, which is algebraically. We did domain from a set of points, which is all the x values. When you do domain and range from a graph, you're looking at the values that are covered on your graph for domain from left to right and for range from bottom to top. The answer is given in interval notation. Solid dots are like brackets. Open dots are parentheses because you can't include those points. Arrows would be infinity. An arrow to the left would be negative infinity, or an arrow down, if you're doing range, would be negative infinity. An arrow up or right would be positive infinity. Increasing, decreasing, and constant behavior, you're also going to find from a graph. So the most important thing is that you're reading these from left to right. So you're going to start left and you're going to work your way right. If your line is rising, thank you, as you move from left to right, that's increasing. If it had like almost like a positive slope, except these won't be lines. If it's falling as it moves from left to right, then it's decreasing. And if it's horizontal, it's constant. The answer is again given in interval notation, and they are open dots if the graph starts, or the graph starts or stops constant. So if I have a single point where my direction changes, that point cannot be decreasing and increasing. We give it a parentheses. So the only time open dot or bracket is going to happen is if my graph starts constant like this, and then it could change so it's decreasing, and then it could change so it's increasing, something like that. This would get a bracket, or the reverse if it ends. So let's say it does this, and then it ends constant, then it would get a bracket. Everything else in increasing and decreasing gets a parentheses. All right, so these examples say find the domain, the range, and the increasing, decreasing, constant behavior. So we're going to look at the first one. This is what a piecewise function would look like. The first thing I'm going to do is find domain. So domain is my values from left to right. What's the furthest point left graphed on this? -3. Does it an open dot or a closed dot? It's open, which means what in terms of interval notation? Parentheses, good. Then it goes until it hits here and it takes a break, so we have to account for that. So what's the end of that range? X, Y's. 0. So it goes from -3 to 0, and this time it's a solid dot, so it gets a bracket. Then my graph stops, so I have to stop the interval notation and start it again. It picks back up here. What's the X value there? 2. And it's an open dot, so 2 with the parentheses. And then it continues on in this direction, and there's an arrow. So what's that tell you about your X values after this? Good. It's going to go to positive infinity. And infinity always gets a parentheses. Yep. Go. Yeah. No, I mean, you could put a U, you could put a comma. Actually, let me look and see what WebAssign does. Okay, then we do range. Now, range is bottom to top. So what's the lowest Y? 0, right? It's here. And then it goes up to here. It takes the break again, so I have to start and stop it. So the lowest range would be 0, and it's a parentheses because it's an open dot. Then it goes up to here, and my value there is at 2, but this time it's a solid dot, so it gets a bracket. Then there's a gap, so that's why we start and stop the range. It picks back up again here. What's the Y there? 3, and open dot or closed dot? Open, which means parentheses. 3, 2, and what's the biggest Y? Positive infinity. So range left to right, domain left to right, range bottom to top. Now we do increasing, decreasing behavior. So we're going to find all the spots in which this graph is increasing, all the spots in which it's decreasing, and constant. If there's none, we just leave it blank. Or actually, not leave it blank. We put none. I think on WebAssign it's DNE for does not exist, but I'm going to look that up right now. So increasing is, so I'm looking from left to right always for increasing, decreasing behavior. So as I'm looking from left to right here, what is that first part of this graph doing? Rising or falling? Rising, which means that is increasing. So it is increasing, and we do the X values. It's increasing from -3 to 0. And again, always parentheses on increasing and decreasing, because a point itself cannot be increasing or decreasing. Then it stops again, and it starts here. And is that rising or falling? It's rising, right? This is still rising. And it's from 2 to positive infinity. Is there any part of this graph that is falling or decreasing? No. So there's none. And constant would be a horizontal line. There's also none. All right, so let's try 2. Let's start domain. So furthest point left this time is what? It's an arrow pointing left, right? Which means negative infinity. And then it goes to what point before it stops? -2. Parentheses because it's an open dot. Then it stops and it starts again at +1. And it gets a bracket this time because it's a solid dot. And then it stops again at 2, and it gets a parentheses because it's an open dot. Then we do the range. So for range, we're going bottom to top. What's the lowest Y? Good. It's an arrow, so it's negative infinity. Then it comes up to this point, which Y would be 0. It gets a parentheses. It stops, and it starts again at this point. Y would be 1. and it stops at this point, y would be 2. Oh, this should get a bracket, sorry. That should get a bracket. And then 2 would have a parentheses because it's an open dot. Make that neater. So domain and range, solid dots are brackets. Open are parentheses, and infinities are always parentheses. Then we do increasing, decreasing, constant. So this first part would be what? Increasing. As I move from left to right, it's rising, right? So from negative infinity to the x value there, which is negative 2, it's increasing. And then my graph stops and picks up again here. It's again increasing, and this time it's from 1 to 2. Both of them get parentheses. Yeah. So you're going from left to right. Like, look where the very first dot is, and as you move from left to right, it increases. Yep. All right, then the last one. Oh, because there's no decreasing here. None again, and none. No decreasing, no constant. Look at the last one. Start with domain. So furthest point x is what? Negative infinity. So this arrow is going to keep going up, but it's also going to keep going back, which means negative infinity. Then it comes to here and it stops. What's the x value there? Negative 3. Bracket or parentheses? Good. Parentheses because it open dot. Then it stops. So does our domain. Then we start it again here. That's a negative 2. This time it's a bracket because it's a solid dot. Goes all the way through to here, which is positive 1, open dot. Stops again. So our interval notation stops. Starts again here, positive 3, open dot, so it's a parentheses, and arrows to the right, which means positive infinity. Then we go range. Lowest y here is what? 1. Some of those dots are solid dots and some of those are open dots. If there's a solid dot on that line, it gets a bracket, we include it. So this would be starting at 1 with a bracket. And then this is just 1, but this continues up, and so does this. As long as there are values plotted on the y anywhere on my graph, I count that part of my range. So even though this one's only on the 1, these both continue up. So this starts at 1 and keeps going up to positive infinity, which is what my range is going to do. It doesn't matter if there's an open dot somewhere else. If there is a point at that y, we count it. Okay, now increasing, decreasing, and constant. So again, we go left to right. I'm going to clean all this up so we can look at it clear. The furthest point left would be here, right? And it's going this direction. Increasing or decreasing? Decreasing. Good. So from negative infinity to the x here, which is negative 3. Both gets parentheses. Because it's now we're falling, right? The highest point was up here, and now it's coming down. Like this is my first point as I look from left to right, right? That's the farthest one. And then this is falling, so it's decreasing. The next one is here, and it goes like this. What behavior is that? Constant. So it starts at negative 2, and this time I can give it a bracket because that point did not come off of an increasing or decreasing. If it was shared by an increasing or decreasing, it gets a parentheses, but that starts constant. And then it continues constant until you get to here, which is positive 1, but that's an open dot, so it gets a parentheses. Then my graph stops, so does my increasing, decreasing behavior, and starts again here. And this time it's rising as I move from left to right, which means that part of your graph is what? Increasing, decreasing, or constant? Increasing. Good. So it starts at 3, and it goes to positive infinity, and they would both get parentheses. It's similar, but like if you add all those parts together, you mean?
No, like for the first one, the increase.
That's only because the whole thing was increasing. Yeah. So notice this time our domain is really made up of our increasing, our decreasing, and our constant. That's because we're doing the x values, those should match, but all three parts combined. Yep. Questions? Yeah. Okay.
For the third one, how come for the range, like the first line, no part of it? Like the one.
This one? Oops. This?
For the range, like why is only the second and third line are part of it?
Why does always, say that again?
Like why is like infinity to 2 or something? Like the blue arrow.
Yeah.
Why is that not part of the range?
We're already, because we already said this, it's already included in that. So you would just be saying it twice. That's all.
Oh.
Yeah. So as long as this is already included in these points, which it is, you don't have to restate it.
Oh.
For that one, why wouldn't you say that the range is -1
Because you're going the y values.
Oh.
So the y starts there, right? Lowest to highest. Range is y. The like increasing, decreasing, constant, and domain are both x's. But the range is the y. Lowest point to highest point. All right. So now it says, find the domain, the range, the decreasing and increasing constant behavior, and then evaluate the function at the indicated value. All right, so the first one, my domain, again, going left to right, would be -2 with a parentheses because it's an open dot to 0, which is this one here. This would be -2 to 0 with a bracket. Then it stops and it starts again at 1, so it's an open dot, which is a parentheses, and it goes on to positive infinity. My range from bottom to top, lowest y is this -4. And then I have a range that goes all the way up here and overlaps it over here and ends with an arrow. So that's why it's to positive infinity. The first part is decreasing. So decreasing from -2 to 0. And then it changes to increasing from +1 to positive infinity. And there's no constant. Yep.
How is -2 to 0 decreasing?
So this is falling as I move from left to right, right? Yeah. You're welcome. Okay, for 5, I've got arrows going both left and right, so my domain is all real numbers, which is negative infinity to positive infinity. My range, the lowest point here is at 1. It's a solid dot, so it's a bracket, and then they point up, so it's positive infinity. It is decreasing first, so from as I move from left to right, is decreasing from negative infinity up to 0, and then it changes direction and it increases on the second part, 0 to positive infinity. Again, no constant. For 6, my domain is going from -5 to -3, parentheses on the -5 because it's an open dot, bracket on the 3 because it's a solid dot. It stops, so I stop my interval notation. I start it again. -1 to +1, open dot, so parentheses, solid dot, bracket. It stops and starts again at +3, and then my arrow would point down, but it would also point to the right, which means my x are going to keep getting bigger, which is positive infinity. My range is bottom to top. So the arrow pointing down says negative infinity is going to be included. And then the highest point as I move up is this point right here. It's an open dot, so it gets a parentheses, and it's at the 3. It is decreasing first. So from -5 to -3, it's decreasing. Then it increases from -1 to +1. And then it decreases again here from 3 to positive infinity. And those are all parentheses because increasing and decreasing never gets a bracket. Only constant can get a bracket. Questions on that so far? Okay, so then underneath it, like think about what this typically means. If I had an equation and then I told you to find f of 0, what are you going to do? Good. So you're saying my 0 is my x, right? Whatever's inside the parentheses is the x. So now what if I told you, here, use this graph and tell me what values have an x that's 0? What does that look like? Where's x 0? The y-axis, what point is there? This one, right? right? It would be 0, -4. So what's the y on that? -4. So this terminology or that format, that f of 3 says, if x is 3, what is your y? That's basically what you're trying to find. So if I go to where x is 3 and x is 3 here, so I have this coordinate point here, what's the y? It's a point, so what's the coordinate on it? Nope. What would this coordinate point's name be? 3, 0. So the y is 0. These will always be values, never infinity. All right, go to 5. F of 0. So again, 0 is this line here. My coordinate point is here. What's the y value? 1. And the last one, -3. So -3 is here. What's the y value? 1. And +1, what's the y value? 1. So you will oftentimes see like f, like let's say it says this on a standardized test, and that is literally just a coordinate point disguised as a function point. So this is really just 0, 1. That's all that is. Standardized tests love to put things in different format just to confuse you. But that means the same thing. All right, even and odd functions, okay? An even function is something that is symmetric to the y-axis. So if I could take my graph and I could literally fold it like a hot dog, fold it down the y-axis and it overlaps, that's symmetric to the y-axis, and it is also even. So there's a couple ways to test for it. The first is from your graph. If you could literally fold it from left to right and it overlaps, then it's even. The second is from an equation. So in an equation, we take the f (-x), which is really the y, and we change it to -y. I'm sorry, other way around. We do the x. We take the -x and plug it in place of the x. And if my equation goes back to the original, which you'll see what that would look like, or everything is the exact opposite sign, then I would say it is an even function. If I'm testing for the odd function, now if I plug the negative in and each term changes sign, that is symmetric to the origin. And if it's symmetric to the origin, it is odd. So think origin and odd both start with an O. The last kind of symmetry is x-axis symmetry. This is if I fold it from top to bottom, okay? Now the test for that would be to see if y is raised to an even power or an absolute value, because that's what's going to make your x go away. But that would fail your function test. So no function can be symmetric to your x-axis, okay? If it was symmetric to your x-axis, it would look something like this. And that would fail your vertical line test, okay? So functions cannot have x-axis symmetry. They would fail the function test. So you're really just seeing if it's even, which means it's symmetric to the y-axis, or it's odd, which means it's symmetric to the origin. So in both cases, we're going to plug in a -x. If it goes back to the original equation, it's symmetric to the y-axis, which means it's even. If every term changes sign, then it's symmetric to the origin, which means it's odd. All right, they'll look like this. Determine if the function is even, odd, or neither. First things first, it has to be a function. So what's our test for a function from an equation? What can't y be? What would make it fail a vertical line test? Yeah. Good. So raised to an even power or an absolute value. If either of those happen, it's not a function from the beginning, so it can't be even or odd. So it can't be raised to an even power, and it can't be an absolute value. So that's the first thing you want to look for. Are either of those happening with number 7? No. So I know it's a function. Now I'm going to test. I'm going to take x and I'm going to replace it with a -x. So I'd get -x to the third minus a -x. Now what happens when I raise a negative to an odd root? I mean an odd power. It stays negative, so this is going to be negative x to the third when I simplify it. How about minus a negative x? What happens there? Plus x. So if now I want to compare this to my original. If they match, then it's symmetric to the y-axis, which means that it's even. If both are the opposite sign, then it's symmetric to the origin, which means it's odd. So are they the same? No, so it's not even. Are each the opposite sign? Yes. So this is odd, okay? Or symmetric to the origin, because those mean the same thing. Okay, go to 8. First test to see if it's a function. Is this a function? Yes, the y is not an e raised to an even power and the y is not an absolute value. There's not even a y there, right? F of x is your y. So now I plug in a negative x. Negative x squared plus 1. What happens when I raise a negative to an even power? Goes back positive. Does this match the original? Yes. So this is even, God bless you, or symmetric to the y-axis. Yep.
Why did you plug in the negative 1 to the first problem? Put in a negative to the first problem on the negative x?
Because there was an x there. This time it's a value, so I can't change it. So anywhere there's an x, you're plugging in a negative x. Yep. All right, 9, obviously, again, a function because the y's, again, there's not even a y there to be raised to an even power or an absolute value. So now I do 5 minus 3 times negative x. What's negative 3 times negative x become? 5 plus 3x. Does this equal the original? No. Are both opposite signs? No. Only one is the opposite sign. The 5 didn't change. So this is a neither scenario. Every term has to change signs in order for it to be odd.
For what sign would we put DNE?
I actually think it's multiple choice. Even, odd, neither, and you get 3 options, so let's get this right, folks. You don't get 3 options on your quiz, so get it right the first time. Yeah.
What does it say next to even for number 3?
It says symmetric to the y-axis. That's what even means. All right, so now this says determine if it's even, odd, or neither, then determine if it has symmetry. So we know one leads to the other, right? So look at 10. I'm going to plug in the negative x to the fourth, minus negative x to the second, minus 1. What does negative x to the fourth do? Goes back, well, it's raised to an even power, right? So it's going to go back positive. Then negative x to the second makes this positive, but this negative is still there. So minus x squared minus 1. Compared to your original, what's true? They're the same. It's the same, right? If it's the same, it's even. And if it's even, what kind of symmetry? Y-axis symmetry. So that's the 2 parts. Figure out if it's even, odd, or neither, then determine if it has symmetry. Now 11, plug in the negative x again. Negative x to the third power, what happens there? Keeps the negative, so this ends up being negative 2x to the third. And then positive 3 times negative x becomes negative 3x. It does not match. Are they both the opposite? Yes, so this is odd, and if it's odd, good. It's symmetric to the origin. And remember, again, it can't be symmetric to the x-axis and still be a function. So if it has an f of x in it, it's not going to be symmetric to the x-axis. So even if it's a neither, it still can't be symmetric to the x-axis.
If it's neither, does that mean it has no symmetry?
Correct. Yep. Because it can't be symmetric to the x-axis. Yeah. All right. Zeros of the function. The good news is you kind of did this on last night's homework. So this is the same thing as saying f of x equals 0. When f of x equals 0, we replace f of x with 0, right? You don't plug in. You replace f of x as 0. And this is the same thing as saying the 0 of a function. So on the graph, they are x-intercepts. If you are solving for them, they are called zeros. They are called solutions. They are called roots. Those all mean the same thing. So all we do is set my function equal to 0 and then solve for x. So it says find the zeros of the function. For 12, I'm going to replace f of x with 0. And then you got to figure out how to solve because they're all going to be a little different. What would you do here? You could do quadratic. Could you do anything else? First and last. So 2 times 1 equals 2. Are there factors of positive 2 that sum to negative 3? Negative 1 and negative 2. So 2x squared minus 1x minus 2x plus 1. And then factor by grouping. X, 2x minus 1, negative 1, 2x minus 1, 2x minus 1, x minus 1, and then split and solve. So the zeros we list 1/2, comma, 1, like that. I don't think the order matters. I think it's a list. So you could have done quadratic on that. It would have given you the same thing. You just have to make sure you simplify it all the way to the end. Yeah, you'll literally just list these in comma separated list. All right, then 13. So I'm going to replace f of x with 0. Then what? Solve. How do I solve? So that's when it's inequality. Just get rid of the denominator, right? Just multiply both sides by x plus 5 and x plus 5. What's always going to happen? Always going to cancel. So I can set my numerator equal to 0. Subtract the 5. Divide by 2. What's important about the fact that there's a variable in the denominator? Good. X could not equal negative 5 in this case. That would have been an extraneous root. We are going to eventually learn that those have asymptotes. These are lines that that end up in my graph that cause my graph to start and stop. But for right now, you're just finding the 0, which would be negative 5/2. Questions? So that's where the quiz will stop, okay? It goes from the slope from the beginning of 2-1, which was slope, lines, graphing lines, finding the slope from points, finding the slope from lines, finding the equation of the line, right? If I give you like the point and the slope, parallel, perpendicular, all that stuff. And then it gets into functions. Is it a function? You have to do your vertical line test. Find the zeros of the function, if f of x equals g of x, all the stuff from the homework from last night or over the weekend. And then this stuff, which is basically domain, range, increasing, decreasing, even, odd, and zeros. All that stuff's on there, okay? So I'll probably publish the quiz review tomorrow. And tomorrow we'll do the notes for 2-4 and then also we'll talk about the quiz review.